Assalamu alaikum warahmatullahi wabarakatuh. How are you teachers? How are you students? Are you fine? I am Jana Ahmed Abdul Sadiq and today we will talk about physics in grade 8 and I hope that we talk about heat energy in the previous video. So today we will make a revision for this video about heat energy in physics. So let us start about some lessons and we will cover the unit in this video. So let us start with the first thing, temperature. So temperature, it is one from a fundamental physical quantities. Like length, mass, and time. So, temperature is the measure of hotness or coolness of the body. That means temperature, it is a measure of the average kinetic energy of molecules or atoms of the body. So, let us see that the SI unit of temperature, it is Kelvin, which is K. And also the instrument that is used to measure temperature, it is thermometer. So that means thermometer also have types like alcohol thermometer and mercury thermometer. These like two types of thermometer. We finished about temperature. So let us go for heat energy. Heat energy is the total of kinetic energy of all the particles. That means heat energy, the SI unit of heat energy, it is joule. Okay? And the another unit for heat energy, it is calorie. One calorie, it is equal to 4.2 joule. Okay? That's about joule. It is the SI unit of heat energy. And 1 calorie, it is like another unit for heat. We talk about temperature and heat energy. So let us talk about the source of heat. Source of heat, it is renewable and non-renewable. Renewable means using continuously. And non-renewable means only used only one time. For example, for renewable, like geothermal energy and wind energy and hydroelectricity. Example for non-renewable, like kerosene, petrol, oil, coal, and firewood, and other things. So this means renewable and non-renewable. So also sun is a natural source of heat energy. Sun is a natural source of heat energy. We talk about source energy, heat energy, and temperature. Let us talk about heat transfer. Heat transfer. First thing, what means heat transfer? Heat transfer. What means heat transfer? First thing, heat transfer, like how to make from a hot body to a cold body, like to make a hot body for a cold body, or like from a high temperature to a low temperature. That means the heat transfer. About like the temperature. And also another thing, that heat transfer occurs when the difference between two objects or two bodies or two parts of the same body. This about heat transfer. And also another thing, that the movement of heat stops where the temperature of each object becomes the same. This about heat transfer. So also we know that there are three types of heat transfer, that it is conduction, convection, and radiation. So let us start with conduction, convection, and radiation. What is the difference between them? And conductors heat and heat insulators. So let us start with conduction. We know that conduction can transfer from one body to another. That means from a hot or by means of successive collision between neighboring particles. That means conduction, like it's mainly seen within solid objects, because atoms of solid react or closer to each other, but in gases and liquids it's poor conductor with them. So that means solid conducts heat better than liquids and gases. This about conduction. Also, example to understand conduction, that when you hold a cup of hot water, your hand gets heat by conduction from the hot water. This is a good example for conduction, to understand better conduction. Then let us start with another thing, that the materials which allow the heat pass throughout them are called heat conductors, and the heat insulators, which is the materials which do not allow heat to pass through them. This means heat insulators or poor conductor. So let us start with some examples with heat conductors and heat insulators. Heat conductors, some examples like silver, a good conductors for heat. Here, can you see? Heat conductors. Silver, gold, iron, mercury, steel, and also aluminium, and another things. Okay? And another things for heat conductors. So let us start some examples with heat insulators, which is poor conductors. Example: plastics, glass, wool, dry wood, and also air, oil, graphite, and another things. It is a poor conductors or heat insulators. This about conduction. So let us start with convection. It's difference for conduction, because convection, it occurs only in solids and in liquids and gases. Convection. Convection, it occurs only in liquids and gases. Okay? Or it takes place primarily on fluids, which is gas and liquid. And also, of course, the temperature is different in gas and liquid. But we talk about this, that conduction, it occurs in liquids and gases. It takes place primarily on fluids, which is gas and liquid, and this thing. But convection, it is like heat transfer from one place to another, like by the actual movement of particles of the material medium. This means convection. And also it occurs only in liquids and gases. This means convection. And also, like, for example, for convection, like hot air balloon and a refrigerator and another examples. And also one example for convection, that boiling water also use convection. This for convection example. And also refrigerator, air conditioner, radiator, and other things for convection. So let us start with radiation. Radiation, like heat transfers from one place to another, but without the material medium. This about radiation. Like for one example for radiation, that how to bring the heat of sun reaches the earth by the process of radiation. This about radiation, like an example for radiation. And also about something in wave, that radiation is emission or transmission of energy in the form of wave. And also that heat radiation is carried by an electromagnetic wave called infrared wave. So, and another thing also, that how heat is transferred by radiation in vacuum. Heat is transferred in radiation by radiation in vacuum. So this was about radiation. After that, we will talk about the specific heat capacity. And what means specific heat capacity? Specific heat capacity is the amount of heat energy that needed raise temperature of 1 kilogram mass of the substance by 1 Celsius or 1 degree Celsius. That means the specific heat capacity. And also specific heat capacity expressed mathematically, C equal to Q over mass times the change of temperature. C here is the specific heat capacity, and Q is the heat which can be gained or lost. And M means the mass of the body. And T, or the change of T, which means temperature, it can be like Tf minus Ti or T2 minus T1, which is the final temperature minus initial temperature, or temperature 2 minus temperature 1, because it is the change of temperature. Okay? So that was like the first formula for specific heat capacity. What if we want to know what is the formula for Q, which is the heat that it can be gained or lost? We will use like a crisscross method. After we will use the crisscross method, like so, the first formula, it will be C equal to Q over M times, here point, which means times, the change of T. The second formula, after we use the crisscross, it will be Q equal to C times mass times the change of T, which means Tf minus T1. This is the formula for Q, which is heat. This is the second one. That means all will be multiplied. C, which means the specific heat, times mass times the change of T. After we will find the answer of the change of T, which is final temperature minus initial temperature. Then the third formula, after also we will use the crisscross to find the mass of the body. It will be M equal to Q over C times the change of temperature. That means mass of the body equal to the heat which can be gained or lost over the specific heat of the specific heat capacity times the temperature, or the change of temperature. This is the formula for mass of the body. Then the fourth formula, it will be the fourth formula. If you want to know the change of T, it will be the change of T equal to Q over mass times the specific heat of energy. That means the change of temperature equal to the heat over mass times the specific heat capacity. After that, we know that the change of heat, it is the final temperature minus initial temperature. But what if someone one question said to us to find the initial temperature or how to find the final temperature? We will see that also. That use the normal formula, which Q equal to which is M times C times the change of T. That it can be Q equal to M times C times, in bracket, or wrap the point, we don't need, that means times. If there is no sign here, it will means times T final minus T initial, or that. After this thing, like if we want to find the final initial, first we multiply mass by specific heat capacity. After that, we will put, after that, of course, it will be the answer here. If it is like negative, which is a number, any number, put it, and TF, we will put it like alone. After that, we will shift TI here, or not we shift, like we will solve it with the number which we will came from mass times the specific heat capacity. After we will solve with this number, which means the initial temperature, we will shift it to Q, which means the heat. After that, when we solve it, will came for us the answer for final initial. And also there's something that why we are calling that Q or heat can be gained or lost, because sometimes the answer will come negative any number, like for 3.2 joule. It can be also like that. This here negative means that the heat, it is lost, but without negative, that means the heat gained. So now I think you understand about the heat energy, whatever, like in heat transfer, temperature, and the source of energy, and the specific heat capacity, and also like the three heat transfer methods, which is conduction, convection, radiation. And I hope that you understand from this thing, and like I try to cover the unit, all of the unit in this video. So now I hope that you benefit from this video, and inshallah you understand from this like unit better, and like to understand more and more informations you get. So thank you for watching, thank you for listening.